FRAM is well established as a standalone memory technology and has been a part of the semiconductor industry for over a decade. The technology is proven and reliable, and testing for data retention shows no fails for up to 10 years at 85C. FRAM is also inherently resistant to radiation with soft error rates below detectable limits. Despite the term ferro in the name, FRAM contains no iron and is immune to magnetic fields. The next slide talks about TI's quality and reliability testing procedures for FRAM. There are two types of thermal wear with regards to FRAM cells: thermal depolarization and imprint. Thermal depolarization. The ability of an FRAM cell to retain polarity is dependent on the margin of electrical signal between the two polar states. As the temperature increases, the energy stored in an FRAM cell decreases, making it harder to distinguish between a stored 1 and a stored 0. This effect is known as thermal depol. It is temporary and lasts only as long as the elevated temperature condition exists. Imprinting is the stabilization of polarization into a particular state. Once same-state data is imprinted due to continuous writes to FRAM, it becomes harder to switch the data to the opposite state. Both these effects are studied and tested when qualifying FRAM. Like all non-volatile memories, high temperatures are used to test the failure mechanism of FRAM. A generalized data retention test flow for FRAM is shown in this slide. The procedure begins by baking an initial data state referred to as same-state data at a high temperature for a specified amount of time. Imprint testing then switches the state of the data, and after a further bake, the data is read out and verified. The opposite state depolarization bake is performed at 85C, the maximum operating temperature for the device. Based on the data retention tests, it can be summarized that FRAM shows no fails post a 100-hour bake at 150C. This data is extrapolated as a 10-year lifetime at 85C. The bits are also long-term baked in the same state to maximize the amount of imprint. No fails were seen at 85C, which is the maximum operating temperature for the device. What about reflow? While the temperature at which thermal depol occurs does not fall within the normal operating temperature of the device, it is important to note that hand soldering a device may cause temporary loss of data. For this reason, the device must be programmed only post-soldering or post-reflow. The reflow temperature is restricted to 260C for a window no longer than 5 minutes. Using a socket connection when evaluating is also recommended.